Hello everyone, welcome to Geotechnical Engineering. I, Professor Praveen Nikam, welcomes you. Today we are learning about a experiment that is a standard Proctor test. So let's see the experiment. For this experiment we require a weighing machine, mold, soil sample, water, collar of the mold and a rammer. So let's start the experiment. First of all, we take a weighing machine. Then we took a mold which is filled with, or its weight of mold is measured with the using weighing machine. We take a soil sample. Uh, we add some particular water in it. Then we take some part of the soil, or we fill the container, or we fill the mold in 3 layers for standard Proctor test and 5 layers in modified Proctor. So we take one particular amount of soil and give 25 blows with the help of a rammer, which is weight is 2.86 kg for standard Proctor test and 8.49 kgs for modified Proctor test. So for we fill the mold with 25 blows of 2.5 kg rammer. So we remove the collar and wet the soil mold with the using weighing balance, and we calculate the weight of soil and a water content, particularly that point, and from that we can calculate wet density and dry density of soil. So let's see how to calculate a dry density as well as the wet density of soil. So wet density will be calculated is equal to mass upon volume of the soil sample. So what is the mass? This is the mass 1547.92 gram, and the volume of sample is 949.41 centimeter cube. After solving this divided by 949.41, so we'll get 1.63 gram per cc, which is called as a wet density of the soil. Okay, so we have to be found out the dry density of soil. So dry density is nothing but the dry density is nothing but the wet density divided by 1 plus W. So we know the wet density, that is 1.63, and 1 plus, this is the water content 8.35%, means this so W is equal to 8.35 upon 100, that is 8.35 divided by 100, that is 0.0835. So put that values in 0.0835. So calculate it. That is a 1.63 divided by 1 plus 0.0835, which is equal to 1.5. Okay, so the dry density is 1.5. So we plot a graph for dry density on the y-axis and water content in the x-axis. So for 8.35% of water, our dry density is 1.5. For 1.68 of dry density, our water content is 10.11. So here it is somewhere lies. So after plotting the graph of this dry density and water content, we get one particular graph like this. So for the maximum value of the dry density, which is called as a maximum dry density MDD, we calculate a optimum moisture content OMC. So here from the graph, the optimum moisture content is 12.38 and maximum dry density is 2.04 gram per centimeter cube. So in this way, we can calculate the dry density or compaction by a standard Proctor test. The difference between standard Proctor test and modified Proctor test is just that the mold size is getting different. The rammer for standard Proctor test is 2.5 kg. For modified Proctor test, the rammer weight is 4.89 kg. Same as the the dropping height is 0.31 for standard Proctor test and 0.45 for modified Proctor test. So the basic filling of the mold by a standard Proctor test for 3 layer for standard Proctor test and 5 layers in a modified Proctor test. That is the difference between these two methods. Okay. Thank you for watching.